Hello, my name is Cooper Hickmott, and today I'm going to be going over an introduction to C and C++ abstract data types and invariants. So I'm sure that you've heard the term before, but what exactly is this idea of abstraction? And all it really is separating what something is from how it works through the means of an interface. An easy example to see this in action is when thinking about a car. So how does a driver control a car? Well, they are given a gas pedal, a steering wheel, and maybe a couple other small buttons and knobs that they can tweak to actually control and use the vehicle in the way that they intend to. Now, what's actually happening under the hood is the accelerator is connected to the throttle, which then regulates the air and the fuel intake proportionally to how far the accelerator is being pushed down, yada yada. Who actually cares? All the driver needs to know is how to use the gas pedal and the steering wheel. Now transition this to more of a coding example. How do we let a user control the actions within a video game? Well, we'll give them a simple handheld remote that they can then input whatever they want to. Now on the programming backend, they will have to interpret the inputs from the controller relative to whatever state that the program is actually in right now. So whether that input is a character's move, changing some game's settings, or force quitting the console entirely. That's what the program backend takes care of. The interface doesn't need to know that. And this is the power behind abstraction. You don't actually need to know every implementation detail. You just have to know how to use this tool. Before talking about abstract data types, let's just review what a data type is in general. So formally, a data type is a declaration defining the characteristics of memory storage for a data element. So some examples that we've seen before are some of the primitive data types in C and C++, such as integers, characters, and booleans. Now, extending this idea of abstraction from the previous slides, an abstract data type is just a data type that separates its interface from its implementation. Some examples of abstract data types in C++ are the standard template string and vectors. So this is just a side note. In C++, abstract data types encompass both the data itself as well as functionality on the data. And today we will only be covering implementing C abstract data types. So now that we know what an abstract data type is, how might we actually use this in some C++ code? So considering the code on the screen, let's just walk through it. So we first will initialize an std string to Johnny. Then we will create an std string study buddy uninitialized. Then we will step on line 10, we will check to see if the length of that uninitialized string is 0, which it will be. We'll then set that string equal to the eex280 staff. Then on line 13, we will compare these two strings together. And if they are not equal, we will output string 1 and string 2 are the best study buddies. Now the key here is that we were able to use these functions such as length, operator, not equals, and printing them out on the string objects without actually having to know how they work under the hood. And this is the whole idea behind an abstract data type. We don't actually need to know how these functions work. We just need to know what they do and how we can use them to our benefit. So now that we know how to use abstract data types, let's talk about creating them. So the C language only has supports for structs with data members, which are also called member variables. And this is sufficient to represent the data of the abstract data types. However, in C, the functions that actually operate on the data must be defined separately. So consider the code that's on the screen. On the left side, we're defining a struct person, and in that we define member variables string name, string country, integer age, and integer favorite number. On the right side of the screen, we can see that the person init function will return a struct person, so it's going to return a struct object of type person, and then some of its inputs are a person, object p, string name, string country, the integer age, and the integer favorite number. And all this function is going to do is set those values to p. So the way you actually do that is with that dot notation. So p.name is accessing the member variable name in that p person object, and then it's set in an equal to the input name, as well as the rest of those member variables, such as country, age, and favorite number. So void print person is going to intake a person p object, and then it's just going to print to standard cout the name, age, where they're from, and what that favorite number is of that object. Int main is fairly straightforward. We're going to construct a person object called myself. We're then going to initialize myself using those parameters, and then we're going to print that. And this is really the basics of creating and then dealing with abstract data types in C. The key is that we have to define the struct separately from the functions that actually work on the struct themselves. And from this, we can now define our own custom abstract data types and write functions to perform operations on these data types. So this is going to give us a lot of freedom and opportunity to really code what we want and make our code more well suited for the problem at hand. So now that we know how to make and use these abstract data types, what if we want to assert that the object that we're currently working on is valid? So let's look at an example. Suppose we want to define a triangle abstract data type, and our goal is just to determine whether or not this triangle object is a valid triangle. And what a valid triangle means is up to the programmer, but in this case we're going to say that is that all side lengths are positive numbers, and that no one side length is going to be greater than the sum of the other two side lengths. So as you can see on the screen, we define our struct object with member variables integers a, b, and c. And then on the right side of the screen, we have an assert valid triangle function, which is just going to input a triangle object t, and then it's just going to calculate, it's going to check whether or not all the side lengths are greater than 0, and whether or not the sum of one side length is greater than the sum of the other two side lengths. And that's going to return the logical AND of those two Boolean values. So in main, you can see that we construct a triangle object, which is 3, 4, and 5, which, if you know, is a Pythagorean triple, so it will be valid. And then we use this function that we defined above, storing its output in the valid variable. If it's valid, we'll see out that it's a valid triangle. Otherwise, we will say it's not a valid triangle. And can really just, and this is the idea behind an invariant. So an invariant is just the structure of the object. It defines what is allowed and what is not allowed. And you can really extend this idea of an invariant to all of the data structures that you have learned and will learn. They all have some set ordering, and the invariant is that ordering. So if you check the invariant, you can check whether or not that object is valid or not. So now that you know all about abstract data types, what was the point of it all, and how does this actually help us? I remember when I first learned this, I definitely did not grasp the power behind this concept of abstraction, but it's really, really powerful, and you use it everywhere in your daily life. Just that notion of not needing to know exactly how and why this works, but just that it does work, and this is how to use it. It's a very powerful programming concept and just engineering principle in general, and I hope that this can give you some insight into how to incorporate that into your coding life.